over 6 years.
But I'm really glad you feel like deep down like it's annoying.
No, we know each other. Like everybody is wrong.
Different generation.
I don't know how to play.
Guys, my sister's Jedi.
I won't be like.
All right, so shh. Nice chat, nice chat. I say nice chat, not chat. No.
Nice.
All right, so that's question 25. A lot of people have a question about this one, and but it's not so bad. It's because the graph is g prime of x. If it's g prime of x, then
What? Wait, I don't know where plus 7. Like, I understand the error margin, but why is it plus and
because you can get
bigger
more
or smaller?
Yeah.
Okay. That's what I assumed. Nice to know. It's all hers. And then I was trying to figure out yeah, I know it's happening now, but now it's I think the problem is that oh, you did they're just doing like a Christmas thing together. Yeah.
What?
And then you can explain one of the graphs. One that
Yes.
So that was a nice one. He's a good one. We think
no.
yeah, he did.
Check your home.
Yes.
No. So this is one question. Which question you may explain, Miranda? This is one of them, 25. So basically 25 is different than 24, but 23, sorry. 23 is you look at the slope. You see the slope is for 23 is go down to right 4 is -1/2. So basically your equation tangent line is gonna be using the equation tangent line to approximate a value. So let's say 23 here is some type of graph that going like something like this, and at this point here is gonna give you this one is 2, this one's 4. So you can find the slope of that line. And this point is gonna be 2, 1, so it's gonna be y minus 1 equal to -1/2 times x minus 2. Does that make sense? Because this is the equation tangent line. Maria, does that make sense? Now, if you want to find out where's 2.04, just plug in 2.04 right here. Because we want to find out that line, what happened is 2.04. So then it's going to be y minus 1 equal to -1/2 2.04 minus 2. So it'll be -1/2 times 0.04, which is -1/2. It will be -0.02 y minus 1. So y equal to 1 minus 0.02, which is 0.98. Does that make sense?
Yes.
Yeah, does that make sense?
Yeah.
You asking Siri?
Yeah. No, I'm not. I was ready. So when he asked, like, oh, do you understand? So sorry, wait, don't understand.
What?
Like the 3.0 things on
2.04. They wanted you to approximate 2.04. Original the question, like question 21 to 24, they say use differential and the graph of f to approximate f of 1.9 or f of 2.04.
Okay.
Yeah, you should plug in both to find out both values. Yeah, you look at this line, look at this slope, because this slope is the equation tangent line. Shh. I cannot talk over you guys. Everybody has a question. So this is 2, this is 4, so you know the slope is going to be negative 1/2. So that's why it's a negative 1/2. The point is 2, 1, so there's 2, 1. And then you just use that line, and if you want to approximate value, just plug in a value into that line, you can approximate the value. Because the value is very close to 2, so it's going to be pretty accurate. Got it? Now 23 is a little bit different because 23 is give you g prime of x.
What's 25?
Or 25, so they told you the slope at that particular point, which is that time the slope is going to be negative 1/2. But they also told you g3 is equal to 8. So you can plug in 3 and 8 here, and then you can approximate 3.1. You can get a value. Very easy question, very simple. They're not like super complex.
What does like the coordinate like represent on the graph? Like if like the that one, like the graph, like for example the 3.1 and then the 7.95. Like what would that like represent?
Okay, so this is 3.8. 3.8, that means original graph has something is 3.8. So that'd be 1, 2, 3, 1, 2, 3, 4, 5, 8, something like this. And it's gonna be a negative slope like this, negative 1/2 slope. Because this is 1/2 told you the slope of that line, because this is g prime of x. The output of g prime of x is a slope. So it's gonna be this line. So what does 3.1 mean? That means I plug in 3.1 into this equation. What will be the output? What will be the output of that value? Because that tangent line is an approximation. 7.95. Does that make sense?
Can you do 27?
Sure. 27 is a equal to x squared. The reason why is a tile. Look at your floor. There's a tile. It's not a tile, but they are. I think this is laminated. This is not actual tile, but sometimes it can be like they say is 10-inch by 10-inch, so it's much smaller than this. Now, every time you have a machine, when you cut something, there's gonna have some type of error, because not every machine is gonna cut 100%. If it's human cut, it's gonna be even more error. But if the machine is cutting, then it's the person that pushing the tile into the machine. If they push a little bit to not toward the edge, then the cut is gonna be off. And when that cut is off, there's a margin of error. In this case, it's gonna be 1/32 inches, which is very, very small. 1/32 inches is about 0.2 centimeter. So it's barely a hairline. But still, it's going to cause some type of propagate error of an area. So in this case, 1/32 is your dx, because that's small changes. Now, if you multiply by that, that's going to give you an error in terms of the error on the area, and this is going to be 5/8. Now, the reason why you have plus minus, because sometimes you're going to have cut less or more. So it depends, how you push in the machine. Sometimes you are going to cut it wrong way. You're going to have less or more. Like sometimes you see it in nutrition label as well. They will say plus minus 2 grams of sugar. They will have says, one serving is like 2 grams of sugar and plus minus 0.2. So that means that they cannot be very precise on how much sugar, like say a gummy bear is. But they can give you a generalization of there might be a margin of error. And that's the uncertainty. We cannot, it's outside of our control. It doesn't matter how accurate the machine is, it's gonna have some type of error. And that's called propagate error. Now, if you take this propagate error, sometimes the question asks you a different way. They say, hey, ask you percent error. You're gonna take 5/8 divided by 100. Why is 100? 100 is total area. Because 10 by 10 is 100. So you can say 5/8 over that, over 100. And they will give you a percent error. A percent error is going to be like, I don't know. In this case, it's probably like 0. It's about like 0.65% or something like that. I don't know what 5/8 is. Yeah, the 625, yeah. So it's 0.625% or 6.25%. I don't know the calculation of that, but anyway, that will give you a percent error. Now let's talk about square root of 99.4. This is the way I teach you how to do it, but this is a way to use equation tangent line to do it. I like this way because it show you why is a 10 come from, because you got 110. Why is 110? That is the point that you know of for sure that's existing on the actual graph. Why? Because square root of 100 is equal to 10. So 100, 10 here. The m is a slope, which is in this case is 1 over 20, plug in 1 over 20. You can evaluate the x. X is 99.4. You're going to see that this side is negative 0.06. And that's your dx. The dx is negative in this case. I think Maya is asking why that dx is negative. Because 99.4 subtract 100. Because it went from 100 go down. Because we know the value of 100. But if the estimate value, what we're trying to estimate is 99.4, your dx is going to have a negative sign rather than positive sign. Maya, does that make sense?
Wait, the only thing like I'm confused about these questions is like, you know how the way you taught us to do it, it's like a number plus the dx.
Yeah, and then this one told you where the number come from because of y minus 10, right? You move the 10 to the other side, and that's what the 10 plus that dx. This is dx, and this is the actual thing that 10 is. Because if you use the equation tangent line, you actually see that what happened. Y minus 10, x minus 100. Because at 100, the output is 10. Now the slope is 1 over 20. Now I can plug in here, and you're going to get this, which is same thing as what you get here. But where does the 10 come from? You move the 10 to the other side, it's going to be 10 minus the value, or 10 plus the value. Understood? Ready for the next chapter in?
Like I'm basically already done.
We're going to have one big test.
One big. Big.
Oh.
You mean by big? Like,
Wait, do you want to sleep on it? Just
Yeah, you should sleep on it. You
Yeah.
yeah. Think about it. What is it though? You don't need this.
Oh. Oh, yes.
I feel like going to walk next week. Take as much time as you
there's
need.
a block next week.
Oh, don't.
Not next week, right? I think the follow next week, right?
Yeah, that's not gonna be
For what?
On Friday.
Oh yeah, true. Oh, it's the week of December 12th, because that's when we have the civics
No,
meeting.
it's Monday.
Wait, okay.
All right, so let's talk about math.
We
I'm not gonna.
We are gonna have a CFE here. We're gonna take a big test. That's what I'm saying.
Oh, during the block.
Oh, like of everything that we did.
Oh no, only in integration.
Oh, okay. Wait, when is this?
Whenever, because everybody's different period. We're gonna learn integration today. So right now we're gonna start. Okay, so imagine that if you have f prime of x is equal to 3x squared, what do you think f of x is equal to? Without teaching you, you can probably figure it out. Or smart.
Thank you.
Except she's wrong.
Oh.
No, not she's wrong. I'm just kidding. She's not entirely right.
Is there multiple possibilities?
There are multiple possibilities. There are multiple possibility. We're gonna talk about that. So obviously that you guys don't understand that yet, but that's okay. So imagine like this, right? This we know dy dx is equal to 3x squared. And we say we want to find out what is. So technically the dx is moving to this side, which is it shows up in differential form. And that's why when you're doing differential yesterday, it looks like this. And then what you can do is, hey, let's take integral on both sides. Now the squiggly line is called the integral. Also known as the anti-derivative, which is the opposite of a derivative. In this case, I can even call it the indefinite integral. Indefinite integral. That just means without boundary. Without boundary. Without boundary. So now this is called a separation of variable. You move the dx to the other side and you make sure the dy and x and dx is together. Now I'm gonna integrate both sides. The integration dy is actually super easy, just y. Right, before yesterday we're doing the opposite, right? We got y equal to something, but today if you integrate, just gonna be y. And some of you guys says this is x cubed. And according to Amber and Laura says it's x cubed, which is not wrong, but it's also not entirely right. Now, what Amber says, there are a variety of answers. So what does that variety mean? Well, this is a very important thing. You must write down plus c. If you don't write down the plus c, I'm going to have to take points off on you. It's not because I don't like you, because you're white, black, Hispanic, Pakistani, Indian. I don't really care. So you must have it as a plus c. Okay, why that plus c is important? Because in this case, we're going to call this a general solution. All the general solution, it should have plus c. Now, without plus c, you're going to argue, well, it could be right answer, it could be wrong answer. But think about it. If I have x cubed plus 20, if I have x cubed minus 4, if I take a derivative of those, what am I going to get? It's equal to 3x squared, so it's equal to 3x squared. So this why c is important, because c could be any constant. Because you take a derivative, any c is completely go away. Right, so this is an example here, and to show you this is always equal to 3x squared, so this is known as a general solution. But at times, if you don't write down the plus c, then it's impossible to find the particular solution, because we can find the value of c if additional information is given, or initial condition. But we're not going to get to that right now. We just need to understand that you can take an integral of this. And if you every time integral something, it's going to get plus c. Now, some of you guys going to say, hey, if I integrate this side, don't there's a plus c here, and there's a plus c here. Well, this c can move to this side in just one c. So c can multiply by 2, it's going to get c. C divided by 2 is still c. It just depends on what initial condition. We're going to get to that. That's a little bit tricky. But right now, just for you guys to understand that you take integral, one side, just make sure plus c is good enough.
What happened to dx?
When you integrate, it's gone. And we're going to talk about dx mean later. But right now, just know that if you integrate that, the dx go away. That's the small changing of x. When you integrate that, the dx is gonna go completely away, and that's just a rule. But later on, we're gonna explain why they go away, because essentially, if you do definite integral, then you can see that it's just small change of x. You're finding area under the curve. But we're gonna get to that later. But right now, just know that it's gonna go away for now. And you don't have no more dx. Got it? Okay. Let's talk about a couple things. First of all, basic integration rule. If I have integration of f prime of x dx that's gonna be f of x plus c, right? Now, notation wise, they can also be different. So, okay, so this one is going to be integration of f prime x equal to fx. You guys, know that. If I have integration of capital F prime of x dx, that's going to be f of x plus c. Does that make sense? Just take away the prime. Every time you take an integral, it's take away the prime.
So f can be any variable.
F can be any function.
So the capital F is just like it's equivalent to
If you write in
like the regular
f
F.
of x,
Or like what's the difference between
capital F of x is a two different function.
It's just a different function.
It's just saying it's different. Like you can have in any form. Like you could put
It doesn't matter what function is. If you take an integral of a prime, prime is gonna go away. Yes.
So when you take the integral, like is it for like if there are multiple functions, you need to do each one. Right?
Exactly. We're gonna talk about that. That's a good thing that you mentioned. So if I take a derivative of a constant is equal to 0, right? What happens if you integrate of 0 dx? Well, it's gonna give you a c. Does that make sense? If I take a derivative of kx, it's gonna be what? Okay. And integration of k dx is gonna be what? Kx plus c. Good job. It just.
You're big.
So if I take a derivative of kf of x here, so you can take a k out, and that's gonna give you f prime of x. Does that make sense? I can take it k outside, and just focus on take a derivative of f of x, and that's gonna give you kf prime of x. So when you take an integration of kf of x, the same thing that you can take a k out of f of x dx. You can do that. You can take a k outside. The k is a constant that can be taken outside. Just like when you take a derivative, like it says, you take a derivative of 2x squared, you can take a 2 outside and just focus on the x squared, and that's equal to 2 times 2x. Does that make sense? So when you integrate, it's going to be the same way. Now, according to what Amira asked me, what if you have two different functions? Let's say d to the dx of f of x plus minus g of x. Now, that's equal to f prime of x plus minus g prime of x. Does that make sense? So if you integrate two things, f of x dx and f of x plus minus g of x dx, it can break up to two integral, would be f of x dx plus minus integration of g of x dx.
Wait, can we like hold on for 1 second?
Can you hurry up? Okay.
No.
So you can take a derivative of two separate functions. You can also take an integration of two separate functions if they're adding and subtracting together. Not when they're multiplying though. Okay, when they're multiplying, it doesn't work. Huh? Yeah, it doesn't work with multiplying. Yes.
But after the kx equals k part, like they're down, when you take the integral, like why is the symbol still there? Shouldn't it be like
The symbol there, if you can, you just, You haven't taken the integration yet. If you take an integration, the symbols go away. You haven't taken integration, but I'm just saying that k can be outside. And then you can take an integral after that. Now, I'm going to write something that's very important today, which is the rule that you're supposed to know. Integration of x to the n. What's the integration of x to the n? Can you guys come up with a formula for integration of x to the n? No. How do I take an integration x to the n? The reverse of power rule. How did you get 3x squared equal to x cubed?
N minus n plus
one.
1 n plus 1.
And
Is it plus b?
no.
X divided by n
The n
to the power of n plus 1.
Almost. No.
dx.
No.
X divided by n minus.
X to the n plus 1.
Good so far. Not done yet.
Plus, and then divided by dx.
No,
So
that's
divide
wrong.
by n.
Almost.
Plus d. It's n. It's 2 divided by n plus.
Oh,
Is it x not raised to any power?
no.
It has to.
It has to raise the power because
Okay.
The power has to be n minus 1.
But then you have to divide by,
It's the
when
n
you
minus
when you
1
revert it back,
divided
when you
by
bring it
d
up,
by-
you have to divide by it.
That's what, yeah.
But it's
If you-
n something divided by n
What?
plus
X to the n plus 1.
almost not done yet.
N minus
To the n plus 1.
one. I know the heat.
It's not.
X, like X has
X
to
to
be
the
in
n minus
parentheses,
1.
right?
Or x to the n plus 1.
Wait, does the X have to be in parentheses or no?
Plus 1.
Divided by.
Okay?
Like,
Okay.
What Austin says.
X to the n plus 1 divided by n plus 1.
Oh.
Because it's the number that's up there, you subtract it by 1, so you have to add that 1 back. If you divide it, because you want to get
Because that's a dx.
yeah. So if it was like 4x, because 3 would be at the top, so you'd have to bring the 3 down plus 1 and then divide by it.
It's number is multiple. It's like,
Yeah.
what does that mean? Isn't it like anti-power? It's like what when you're thinking of it, it's like it makes sense. But it's that's not so. Can you explain it?
Is it bad that I'm still stuck on the other one?
Because wouldn't you be?
Because instead, like, the minus power multiplying it. So I think, are these different rules?
Yeah, no. What's x to the 5? Now, put in mind, right? Put in mind. This one is numerator. You must make sure that x to the n is on the numerator. Must make sure that. Okay, it's a numerator. It's not 1 over x to the n. 1 over x to the n does not work. It's only x to the n. Right, only x to the n. Now, how do I do this? It will be x to the 6, right? 5 plus 1 over 5 plus 1. Does that make sense? So it'll be x to the 6 over 6, right? Plus c. Now let's take a derivative of this. What's derivative of x to the 6 over 6? Well, you take the 6 down, and you want the 6 to cancel out. Do you see that?
Yeah. What, is it always gonna cancel out? Oh.
And that's why you must have an m plus 1 on the bottom, and this is m plus 1 here. No, this is derivative. There's no plus c. If you integral, you're gonna have plus c. But if you take a derivative of that, you should go back to before.
And you can only do that when there's a constant in the bottom. Like the power rule on the numerator. And
That's
when there's a constant.
Constant on the bottom. But there's no constant. X to the 5 has no constant on the bottom. That's 1 on the bottom. Yeah, there's only constant.
In this case, it's always gonna cancel out.
and should
Okay, they give you a little bit difficult one.
No.
It's not hard, man.
Me.
1/2.
Good job. You must convert a radical form to a rational exponent form. No, I mean this is an exponent rule from algebra 1. You're gonna have to use this two rule consistently all the time, or 1 over a to the negative n equal to a to the n over 1, something like that. But a lot of time that you're gonna use this two rule in algebra, and maybe quotient rule as well.
It looks like I'm learning.
So what's integration of x to the square root? Can you rewrite that? X to 1/2, good. Then that's equal to x to 1/2 plus 1 over 1/2 plus 1. So that's going to be x to the 3 over 2 over 3 over 2. Does that make sense?
Yeah.
Now, please don't write that. This is a complex format. You understand this divided by this. Does that make sense? So be keep change flip. So that's equal to x to the 3 over 2 times, if you think about it, it's divided by 3 over 2 like this. And that's going to be x to the 3 over 2 times 2 over 3. So it'll be 2 over 3 x to the 3 over 2 plus c.
Wait, why didn't you cancel out with this one?
you're not can't do
You
it.
cannot cancel the power.
You just did it with the other one.
Just use looking at derivative.
That one was making it back into the
Yeah, that
derivative.
was-
He's just making finding the integral.
Like what he did with the checkpoint, make sure.
You can take a derivative of this one. You can cancel out the 3 over 2 and 2 over 3.
But that would be wrong.
Yeah, if you don't want to take a derivative, but right now we'll go with taking integration. So this is a general solution. All right, let's give you one.
What? There's 2 3.
All right, take an integration of this.
Wait, what's your the last one was to the power of was 3/2?
Yeah, 1/2 plus 1. If you take a derivative of that, you're gonna find out the 2 over 3 and 3 over 2 will cancel, and then we'll get to x to the 1/2. So, can I apply power rule at a state?
No.
No, it's not a numerator. So what do you have to do to make it a numerator?
Turn into negatives.
Right? And then that's going to give you x to the negative 2 plus 1 over negative 2 plus 1. And that's x to the negative 1 over negative 1. And that's equal to negative 1 over x plus c. Does that make sense?
Wait. How'd you get that?
Just divided. Make this thing.
He brought it to the column. The negative one. Change the volume.
So you took the derivative?
No. Okay. You don't have x and negative 1, right?
Oh, you just
You know how he moved it from bottom to top? He moved it from top to bottom.
Oh, okay.
Is that okay?
But wouldn't the negative one stay at the bottom?
Just bring it to the bottom.
What's x times 1?
But wouldn't that stay at the bottom?
And then if you did x times 1, it's negative x. So it's just next.
So how do I integrate this?
The thing is still negative.
We can break up to 5 different integrals, right?
No negative.
3 integrals, all right? Uh-huh.
You do them each separately.
Yep, you do them separately.
Oh, I don't want to do it.
Because they are separate integrals. Right, can I just do this? And you can even take a constant out if you really want to. What's the integration of 2x squared? X cubed over 3 times 2, right? Plus 5, x2 over 2, right? Plus x plus c. Does that make sense?
Yeah.
Why are you packing things up?
I'm not packing things up.
Wait, where's that third x come?
Because integration of 1. What's...
I thought that was c.
No.
Isn't it a constant?
Yeah. So which one derivative is going to give you 1?
Oh.
You're lost?
Okay. Wait, where did you get lost? Okay.
Which part is confusing, Maya?
How like you take out the k.
Yeah, you can take out 2 and just take the integration of x squared, 2, like this, right? So it'll be x3 over 3. You can take a constant outside, it's no problem, it's no inference of things.
But why 2x squared?
You can, if you do that, that's fine, but the 2 does not impact anything. 2 is going to multiply at the end. So the 2 can be here, it doesn't matter.
Oh, okay, so you just wrote it like that.
Yeah, I can write it out, so just... Alright, so this one's going to be a hard one.
That's
Okay, think algebra before you do everything. Think algebra, okay? The only thing is like, you always think about algebra before you're doing something.
Wait, can you go back to the answer of the last one?
I know what you're doing. I'm gonna factor it out. I'm gonna do more. Like not factor it out.
Got it? No?
I'm gonna do
Expand them. Split them. I always think about algebra before you're doing calculus. If it's something you can simplify with algebra, just stick with power rule, then you can deal with power rule. But if you try to take an integration right here, this moment is impossible.
I'm not finished. You doing this?
We can split it on purpose, right? So we can do
Extend it.
Is it plus or
It's-
times?
so then you can split
You
it,
do
right?
plus or times?
So
Yeah, I would split it first.
So it's squared, you can expand it.
Wait, you can split it, right?
And then you split it. So then
Yeah.
you can do it.
I think you can only split it if they're being added, if they're being multiplied.
Wait, how many
They're
more?
not being multiplied.
No, but-
Can I expand the top? And I'll write it out like this, so that way I don't make mistake. What is square root of x times square root of x? Plus 3 root x plus 3 root x plus 9, right? So it'll be x plus 6 root x plus 9. So that is going to be x plus 6 root x plus 9 all over square root x dx. Bottom's one term. I talk about splitting, very, very important. Beginning of the year, I keep on emphasize that. I say, please don't do quotient rule, and actually also affect on the integration as well, because you can technically split this like this, right? So can I simplify it down to x to the 1/2 plus 6 plus 9x to the negative 1/2 plus.
You do.
Does that make sense?
Oh,
So it's when you expand. So like the way you think about it, like it's not a constant by itself.
Now, have I taken integral yet?
Like, it's
So it's 1/2 plus 1, right? Over 1/2 plus 1, right? I don't really write that out anymore, but I'll write out for you.
See, that's how it's like if you see single, that's
This one's going to be x to 3 over 2 over 3 over 2. Now, I don't write this out either, but this time I'm going to help you here.
Let's see.
I'm going to do keep change flip, so that'd be 2 over 3 x to 3 over 2 plus 6x plus 18x to the 1/2 plus c. How much time I have?
1 minute.
Challenge you accepted. Let's talk about last question. Don't pack down yet. Okay, so f prime of x equal to 1 over x squared. We already did this one. But I can give you something called initial condition. I'm going to show you here. I can integrate of 1 over x squared dx, which is, you already know that. That's going to be x to the negative 2 dx. That's going to be x to the negative 1 over negative 1 plus c. Is that okay? Now, it turns out this is an initial condition. With the initial condition, you can find the value of c. Believe it or not, it's right here. 0 equal to, well, I know this is negative 1 over x plus c. So 0 equal to negative 1 over 1 plus c. C is equal to 1. So that's going to be f of x equal to negative 1 over x plus 1. This is called a particular solutions. Particular solution. Because this point is given. It's a point is given, you can plug into original to find out what the c value is.
That makes sense.
I found this period.
Oh, you recorded?
Yeah. Chat, do you understand, chat?
you should come on Twitch. You look at gaming, right?
You look like you game. You game?
I like gaming.
Like what?
I don't play the game you guys play.
But like what?
Like if I were to play right now, probably Diablo.
Yeah.
It's like
I don't know what that is.
it's like a top.
I won't play Roblox. You'll kill me to play Roblox.
Your kids play Roblox? Your kids play Roblox?
He had to do a lot of things in order to play. Like he had to do 1 hour math to play 1 hour Roblox. For 1 hour reading to do 1 hour Roblox. My younger son not allowed to play. The older son's already too late. He already started playing, so I cannot take away.
Infinity over infinity.
Huh?
Infinity over infinity.
That's El Hopto rule.
No, you know what stats? How we said the probability of something in that thing. It's one over infinity. Because it's 1 over infinity isn't just zero.
I don't like chocolate cake.
What are you talking about?
So should I have said pick chocolate or else I will make the
So,
card cut out?
infinity over infinity.
I would have picked cinnamon. I like cinnamon roll.
I gotta trash a bunch of cardboard cut out now.
Now, bro, hand them over.
Okay,
Yo,
Corbin.
I
Okay,
haven't
Corbin.
made any cardboard cutouts of you, Mr.
Okay, Corbin.
Wait, cardboard.
So listen, I have not made any cardboard cutouts. Any.
Corbin's being weird.
Is it anything new though, Mr.
Corbin's being weird.
Is it anything new?
It's a cardboard.
A big way of eating lunch here. Lucas not here?
Because we know it. We don't talk about anything. Okay.
Literally like 2 minutes ago, I learned.
Hello.
Oh, the Lincoln Park.
Hello.
Yeah.
But it's not technically one over. But I know.
I like how quickly you went from saying that.
He's not.
What's your favorite?
It's illegal.
What is your favorite food? That's the food you have. It's like the food you have.
All right. Shh. You should have homework done. So can you get your homework out? I'm gonna look at it. Benson, you didn't do homework? We don't? We did.
Yeah.
I don't think you can get it done. It's a lot.
This guy just asked me. She just asked me to come in Saturday. I'm already working 6 to 8. Yeah, I'm right away from this. Oh, 6? Yeah, 6 is like so much better for one evening. I got 96 minus 1. Bro! I love 96 minus. Oh, I don't get Wait, what is Simon Power? There's another game. Fine. Wait, sign I need this fucking don't think you have it. Yeah, like, no, because 3.1 is like, this guy, maybe I did not say. Are you feeling? You know, I know. Yeah, it's good. Oh, it's -1.
Whoa. Is there two different circles, bro? I only did one.
Yeah, that's true.
All right, so the answer of the first one is 1/12. The answer of the second one is 160/3. You guys doing okay so far?
Oh, yeah.
Third one's 9/2. The fourth one's interesting. Is that's bounded by first quadrant. So you have to probably do it in terms of y. Is it better than doing it in terms of x? We're gonna talk about that in a second. Because y only need one integral, x has to do two integrals. 5. 32/3. 6. 11/6. This one is also better to do it in y rather than x. 7 is 14/3. Number 8 is AP exam question. The 7 is AP exam question. 8 is going to be 32/3. I think I put that on last year's test. Number 9, you can use calculator, so it'll be 5.050. 10 is 34. Now that question you cannot do it horizontal because, I mean, you can. You have to break it into two integrals. 11's 2.078. 12 is 1/2. Jing, did I check your homework? I feel like I didn't check your homework. Did you do your homework?
Yeah.
Did you finish?
What do you say the answer was for 10?
10 is 34.
What's the answer for 2?
2 is not a negative number. Just kidding.
What's it for 5?
160 over 3.
160 over 3.
Because we're just probably get negative 160 over 3.
I got the first one. A win is a win. How did you do 2? I didn't why. What are you doing? Oh, I gotta plug in a fire. I'm on body. I've never played one for I say at the time he's not. I was scared, bro. Don't misconstrue.
What's the Nelson sister's name?
I think it's Nicole.
Nicole, like that kid work hard. That kid work hard. Like she doesn't have any math ability, but she works very, very extremely hard.
Oh, I got it because something like at Wait, what?
What the hell?
Yeah. And then she blocked me. I was just like in one game. What? No, you are.
Oh, it's in the first quadrant for 4. What if like
Corbin, you need to stop saying like things I did not say.
No.
can't find anything anymore? It's false allegations, Mr.
No, but the truth is, we all have immature moments. I was immature at a lot of times. Even a lot of time, I will be immature today. So it's not. A lot of times, you are not gonna be mature enough to handle certain things. So, for example, like I was in high school. For example, I was in college. I wasn't immature to handle like a medical school. It's not because I wasn't able to. I was able to, but I wasn't mature enough to handle it. So a lot of time, people takes time to grow, and that's not a bad thing.
Where did you go to college?
I go to UF, and I was doing pre-med, but at the time I didn't mature is because I didn't believe in myself. I don't think I can pass MCAT.
You could pass that kind of.
I could have, yeah, but I didn't believe myself. So that's what I'm saying. That maturity is not like sometimes it's not ability. Don't get confused between ability and maturity. Maturity are completely different. Do I think anybody can handle calculus? Yeah, anybody can handle calculus. There are some people I would say no to, but he's not one of them. But it's a matter when. It matter when is very, very important. All right, so shh. Do I need to go over anything? Any questions? Raphael, how you doing? Good? Okay. Somebody say a very nice thing about Raphael the other day. I don't know who. Kashif, you got it? Everything's good? Okay, Jin? Which one you need to go over? Okay, so I'll show you the solution, but there is some question. It's better to do it in Y rather than things. So